Hi everyone, it's Coach Fred here. And so we just finished up talking about the natural number and compound interest. So now we got to put this all together. So why do we have to know about E and how can it help us with compounding? Well, E is a number that we use a lot when we're talking about exponential functions, and we're going to be spending a lot of time talking about it in the next couple weeks. But with the compound interest formula, I really want us to spend some time comparing and contrasting a couple of things. So this is the compound interest formula on the left, right? We spent some time working on that in class. Let me just highlight it so you can see it. And I really want you to look at it deeply for a second and then think about what we learned with when we looked at evaluating this expression over here, p times 1 plus 1 over n to the n. This was how we came up with what the natural number is, 2.718. And we said as n was getting progressively bigger, this whole expression was evaluating to the value of e. And that was when we let p equal 1. Well, what if we just let it equal p? Well, then it would be p times, this whole thing would be times e, okay? So while we have this compound interest formula when things are being compounded monthly, daily, what if it was being compounded like all the time? So like infinitely. We call that compounding continuously. And so it allows us to take the compound interest formula if we're compounding continuously, which would hopefully you're seeing would be better than even daily, right? Because it's happening like every minute of every second continuously compounding. So taking that money and that interest and putting it back into the original. I'm hopeful that you're seeing that this formula is actually within this formula, okay? So if this is the number E, okay, and I see it exists here, then we can simplify this equation when we're talking about compound interest. And that formula then becomes P times E raised to the RT. And that is when we compound continuously. So if I look at an example, let's look at both of them. Suppose you invest $1,000 at an 8% interest compounded quarterly. That means, remember, 4 times. How much will you have after 1 year? Well, our equation would be 1,000, right? A of t equals 1,000 times 1 plus 0.08 divided by 4 to the 4 times 1, so to the 4 power. Okay, let's evaluate that. Let me get that calculator out. So 0.08 divided by 4 plus 1 raised to the 4 times 1,000. Now I'm doing it, I could do this all in one step, but the reason I'm doing that is I want to make sure you see the proper order of operations that have to take place. So we get about 1082.43. Now remember, this is only 1 year, so the number, so 1082.43. Not a huge number, and it's only 1 year. You might not see such a difference. But if you did this over 10 years, compounding continuously should give us a little bit more money. So if I want to use the PERT formula, it's 1,000, so A of t equals 1,000 E raised to the 0.08 times 1. PE raised to the RT. All right, let's get back to the calculator there, and that's going to be 1,000. I'm going to go to the X button, so second E to the X, and we said to the 0.08. Again, it's not going to be a huge difference because we're only talking about 1 year. So 1083.29. So you can see a little bit more money there. And that's how you use the compounding continuously formula, PE to the RT. In a former life, when I was a little younger and my students thought I was a little cooler, we used to say DJ Fred Dizzle. DJ Fred Dizzle says PE to the RT. So I'll leave you with that. Have a great day.